we go. And I'll just get started. Our presenters, of course, Mark is our moderator. He introduced Dawn and me. Just some overview of our outreach efforts for our new rules from October 2018. We've been trying different formats just to get the information out here to our tank owners and our tank operators. On our website, our division website, we created a section just for the new rules, and this is where you'd go to find the recordings of all the webinars so far that we've done. We also have our newsletter, Tank Talk newsletter, all the past newsletters. You can access them on this new rule tab, and our forms that are in draft for the new rule forms. They are also on this tab if you'd like to review them. We're slowly getting them finalized, so they'll be available for you. And we'll let you know probably in the newsletter as they come final. And if you're not subscribed to the newsletter, just email me or email the tanks.ust@tn.gov or any of us directly, and we'll get you subscribed. Here's just an example of the newsletter. And so this goes out every month, and it just contains about the new rules. It also just topics for UST requirements, information, special topics. It's got a lot of good information in it. And we also provide a compliance toolbox annually to our tank owners, and it has all our forms, the regulations. This is also available on our website if you're interested in looking through it. These are just some of the boxes here that you can access. We also created, you may have been handed out one of these during an inspection, or we're seeing this one too. It's a Trifold Handout. It was just kind of a hitting the points of what's new and what's your requirement to do. I know you can't read that, but if you want a copy of this, we'd be happy to give it to you. It is also under the new rule tab on our website. And before we get started on going through any pictures, things like that, we have to kind of say a disclaimer. State of Tennessee does not endorse any specific brands, manufacturers, vendors, products, services. So anything we're using, for example, it's just an example. We're not putting our name on it. And all the testing that we're going to refer to, all the new testing requirements, the qualifications for the person to do the testing must be conducted by a qualified person. And that's defined by the US EPA as a licensed contractor, certified by the device manufacturer, the person must be approved by authority having jurisdiction. That would be us, Division of UST in Tennessee. Conducted in accordance with division guidance, and can demonstrate adequate experience, or obtain certification from a nationally recognized organization. PEI is an example, Petroleum Equipment Institute. So, spill and overfill prevention devices. What is new? Just for an overview, for spill prevention equipment, your monthly walkthrough inspections, they were already kind of like a monthly spill bucket inspection. There's some new items added to that for the complete monthly walkthrough inspection. There'll be 3-year spill prevention equipment integrity testing. For overfill prevention equipment, also a 3-year overfill equipment functionality testing requirement. And the record-keeping requirements, just briefly, the monthly spill prevention device, spill bucket walkthrough inspections, they'll be maintained for 1 year. On the 3-year testing for spill and overfill devices, those will be maintained 3 years. So you'll pretty much keep it for the 3 years, then you're doing another test, and you maintain that one for the next 3 years. For double wall spill prevention equipment, monthly monitoring results, those records must be maintained as long as this method is in use. And just for review, your spill prevention equipment is required to prevent the release of product to the environment when the transfer hose is detached from the fill pipe, catching any drips, small spills that may occur during the delivery. The spill must be installed on all USTs with a product transfer volume greater than 25 gallons at one time. And this equipment, it's not manufactured or designed to contain petroleum product for long periods of time. It's, it's just to hold that spill until it can be cleaned out. And another example, an all-in-one STP sump as your spill prevention equipment. It may not just be a simple spill bucket. This one, your fill port is actually located with some transition piping here. Looks like your tank probe is in there too. So this entire sump would be considered the spill prevention device. This is some alternative spill prevention equipment. Different sites, different types of facilities. This may be the type of equipment they need to use. This one isn't a vault. These are like a bermed area, bermed surface area around the fill area. And they must be compatible with the stored product and not allow a spill to be released to the environment. And the monthly inspections are required for these type of alternative equipment, and any damage must be repaired or replaced. And this is important. These are a little bit, might be located near like an oil water separator, maybe at a truck stop or a bulk plant, storm drains. These might contain less and be more of an opportunity that they could be a pathway for any spills or overfills to get into the environment. Another type is the spill bucket. They have a drain back valve. So this drain is installed. The intent is, if the product from the hose is in the bucket after the delivery, you could drain that product back into the tank instead of having to remove it another way. But if the spill bucket is not maintained clean, no debris, no water, that can cause some problems with water getting into the tank. And they should not be used especially for fuels that contain ethanol. The potential for water to enter your tank could lower the quality of the fuel. And for repairs, these can be removed and they can be replaced with a device, with a petroleum compatible approved component by the manufacturer. So kind of like a plug. But once it's plugged, it has to stay plugged. You can't take them and, take it out, plug it to test it and put it back in. So for the monthly walkthrough inspection, new requirement for all spill prevention equipment, you will be visually checking them for damage, removing all liquid or debris. You're going to actually look down in the fill pipe and check for any obstructions. Say a stick might be down there to bypass an overfill device. Just make sure there's no obstruction, and you'll be checking your fill cap. Make sure the seal is on it. It has a tight seal, and it sits securely on the fill pipe. And for the double wall spill prevention equipment, if it's interstitially monitored, you want to check for a leak in the interstitial area, and that's monthly. So for the record keeping on the monthly walkthrough for spill prevention equipment, it's going to show a list of each area checked. So each spill bucket, maybe by product, whether each area checked was acceptable, or if it needed action taken. You're going to describe the action taken, say there was water, I removed the water. Double wall spill prevention equipment, you'll keep maintaining the monthly sensor status and the monthly alarm reports if it's monitored with the sensor in the interstitial space. Delivery records are required if the UST system receives infrequent deliveries, and that means maybe your generator tanks, they might get 1 or 2 loads a year. They don't have to do the monthly inspection, but we will require the delivery records. The 3-year integrity testing on spill prevention equipment. Single wall spill prevention must be tested at least once every 3 years to ensure the equipment is liquid tight by using vacuum, pressure, or liquid testing. And the liquid testing is the most frequent. It's a hydrostatic test. Double wall spill prevention can be visually inspected every 30 days or monitored with an interstitial sensor. So the visual inspection would be, some of them have a little gauge, like a vacuum gauge at the bottom. You could visually look at that every 30 days, or you're going to use that sensor for the continuous monitoring. Again, records for the double wall spill prevention monitored with that sensor must be maintained for as long as the equipment is in use and using that method. So we'll be looking at the monitoring records and the documentation that the manufacturer of that spill prevention device requirements are met. If you choose to discontinue that sensor monitoring of that double wall spill prevention device, you must conduct the integrity testing within 30 days.
Yeah, I have a question.
Okay.
This is from David McCaney. There was a comment about the spill basin drain. If plugged, could not be removed to test. I didn't understand that reference. Can you expand?
Okay. What if you choose to remove that drain mechanism from the spill bucket and install, just instead install a plug, you can't interchange that. You can't put the plug in, test the spill bucket, and then put the drain back in. You just consider that, plugged. Once you remove it and plug it, that's permanent. Does that make sense?
I'll
see.
I can unmute David for a moment.
Yeah,
possibly.
yeah. Possibly.
Hear me okay?
Yeah, I hear you good.
Oh, okay.
Yeah.
So, so if you have ever removed the drain and you've plugged it, single wall, double wall, that doesn't make any difference. Once it's been plugged, the drain can never be reinstalled. That's what I'm getting, correct?
I think what my intention is, you don't want to remove it and only plug it for the test purposes. And then, just so you're not swapping it out every time you test it. Then you're not getting an accurate test because you're not testing it with the drain installed. So if you want to put a drain back in, you just do another integrity test.
Okay, I'm following you now. So,
Okay.
So it's not that the drain can't be reinstalled, because there's some people who will decide to just plug that drain so that it's inoperable because it's
Right.
caused problems down the line. But if they choose to install the drain because they want to make it operable again, it just has to be tested with the new drain installed and pass accordingly.
Correct.
Okay, understood.
Yeah. You just want to have, your test representative of what equipment is installed. If it's plugged, you want to pass and test with that equipment. If you put a drain in, it has to pass with the drain.
Okay, good. I can follow that. Thank you so much.
Okay.
Good question,
Well,
David.
good.
Thank you.
For Okay. For the hydrostatic method, and which is the most common method of testing the spill prevention equipment, these instructions are from our division, our technical chapter of our standardized inspection manual, spill and overfill prevention. There's other, testing can also be conducted in accordance with the PEI, Petroleum Equipment Institute, their RP 1200, Section 6. The method would be before testing, you're going to need water, a tape measure or a measuring stick that's capable of measuring to 1/8 of an inch. You might want to use spray paint, a marker, where you can mark that you're going to be able to see. You must clean out the device, make sure it's empty, very clean. Make sure any drain valves are completely closed. If it doesn't seal properly and you know it, that's where you could repair it or, remove it and just not use that, drain valve. But if you want to keep it, you have to repair it and test it with the drain valve installed. And those are a big, a common place for a failed test. Just they could have had debris under it, they can cause some problems. Your fill cap must seal properly. That's important with that. Got the seal tight on top of your fill port. You want to be sure to replace that if it's not, to make sure none of the water gets into your tank during testing and in the future. For conducting the test, you're going to mark inside the spill bucket a level just slightly below the top of that cap on your fill riser. Fill the spill bucket to that level with water, and you're going to allow that water to stand for a minimum of 1 hour. And then after that hour, you're going to measure the difference of the water level using your tape measure from where it started to after an hour where that level is, to the nearest 1/8 of an inch. And then you'll empty and clean the spill bucket. And the test water for those can be reused on site, or it must be disposed of properly. And if the water level decreases by 1/8 of an inch or more, the spill bucket fails the test. And at that point, you determine if the spill bucket can be repaired. So manufacturers have that in place. If not, it must be replaced. If the water level change in the spill bucket is less than 1/8 of an inch, then the spill bucket passes the test. And the division has a form for our spill prevention device hydrostatic test report, Form CN 1366. That's just a picture of it, but that's very small. And if you'd like to have the form, it's on the website, or we could be happy to email that to you. Another method for the vacuum method, this is less common, but it can be done on a single wall or double wall. The device manufacturer has the vacuum testing kits. You definitely want to get with the specific device manufacturer for their procedure and their test times. PEI has some standards here for single wall spill bucket, your initial 30-inch water column, your end result 26 inches or greater is a pass. So that's their tolerance on that. For the double wall, the initial is 15 inches water column, end result of 12-inch water column or greater after 1 minute is a pass. So this is a faster test, but it takes a lot more equipment. And you document your test results on the manufacturer's form, test form, a PEI form, or a form that is approved by the division. As far as repairs on spill prevention equipment, some spill bucket manufacturers allow spill bucket retrofit repairs. There's some that are being manufactured now, so in the event you do have to replace or repair, it's just got that inner, you can just take the inner wall out and you can just replace that. That way you don't have to break concrete to replace the entire spill bucket. And if you do repair, it must be fuel compatible, no field applied coatings or patches, no flex seal. You're going to check for UL approval, or contact us and, make sure what what repair you want to do, and we'll let you know if that's going to be approved. And after any repairs, the spill equipment device must be integrity tested within 30 days of the repair. Also, if you want to look up other types of methods to test the spill prevention devices, the National Work Group on Leak Detection Evaluations, you can always check this to make sure any test methods, not just for these, for, you know, tanks, everything, leak detection. This is a great resource to see what the approved methods are and what the requirements are for that method. For record keeping, so once you have this equipment testing, so 3-year spill prevention equipment testing, you're going to maintain that test for 3 years. The records for the double wall spill prevention monitored with that sensor must be maintained as long as that equipment is in use. The owners and operators must conduct an integrity test within 30 days of discontinuing that monitoring with the sensor. And any repair documentation must be maintained for the life of the equipment. The posted repair integrity testing must be maintained for 3 years until the next 3-year test.
Mitzi, I have another question from David.
Okay. Okay.
If a site has a double wall spill basin, will the state of Tennessee require both primary and secondary testing, or will the primary be the only test required?
If you're monitoring the secondary, you want to unmute him again? If you're
Sure.
testing, yeah, if you're monitoring that interstitial space with the sensor, then you don't have to do the 3-year integrity test.
So if it's being monitored with a sensor, what if the site class is being monitored periodically? So in other words, you have a individual that's doing the monthly and they're inspecting that gauge every 30 days. It's exempt from the 3-year test, correct?
It's only exempt if it's using the sensor. If it's just a visual observation of the gauge in the spill double wall, then it still requires the 3-year integrity testing.
Okay, so on the 3-year test, will you require both the primary and secondary, or one or the other?
So one or the other would be mine. If I would, if anyone of our panelists know that answer for sure, I would think one or the other would suffice. You know, the vacuum test on your interstitial or the 3-year on your primary of the, like, hydrostatic.
Can you hear me? This is Don.
Okay. Hey, Don. Yeah.
Hey, sorry. To answer David's question, if you can conduct a manufacturer-approved pressure vacuum test on the secondary, that would also serve as an adequate substitute for a hydrostatic test on a primary for both, for either one. Does that answer your question?
Yes, sir. Absolutely. Thank you.
Okay.
All right, great.
Great question. Thank you, Don. Thank you, Mitzi.
Yeah, great. Okay. For spill prevention equipment repair and replacement, this is when to contact the division. If it's been replaced, just a preventative maintenance, you want to just go ahead and replace all the spill buckets at your site, you're redoing your parking lot, you know, that type of thing. You don't have to report that unless you encounter contaminated backfill material. Then you'd be reporting that to the division. The failure of your 3-year spill bucket integrity testing, that's not reportable. But if the device is not repaired or replaced within 30 days of the discovery of the failure, the division needs to be notified. That would be a violation. If if the device is replaced and you encounter contamination in the backfill, you would not contact the division. So that would be reported. And again, when to contact the division, when to replace. If you see, you know, of course, obvious damage, you know, that you're going to replace that. You might not even test it first, but of course, you would want to just to verify that it is a fail. The contaminated backfill. If you encounter, you know, obvious visual, you know, or you smell, you know, something obvious, you're going to contact the division and report that. And when to test, of course, after a new installation, you're going to do a integrity test at that time. And failure to repair or replace a defective spill prevention device is a violation, an unusual operating condition. The devices must be repaired or replaced immediately within 30 days or as required by the division. Within 30 days, that's, you know, lately there's been a lot of delay on equipment, and there's just been a lot of reasons that it's taking longer to obtain the equipment, to get the work done. So just be in touch with the division, document, you know, with invoices that it's ordered, it's on the way. It may take 2 months, it may take more. We need document that needs to be documented, and the division needs to be aware of that. Why it wasn't repaired within 30 days or replaced. And of course, this spill bucket must be integrity tested upon installation, replacement, or after a repair. And spill and overfill reporting. This is the 25-gallon rule, which put this in here just kind of a refresher. A spill is fuel released to the surface of the ground during the transfer of petroleum to a UST system. So, and an overfill, that's fuel released during the transfer of petroleum by filling the UST system over its capacity.
Let me just add one thing to this slide. I think it's important to note that the 25-gallon rule only applies to incidental spill during fuel transfer. In no way, shape, or form implies that there's a limit assigned to spills from other parts of the petroleum system. You know, those are not part of the 25 rule exclusion. So I just thought I'd throw that in there.
Right, like overfilling a car at the pump, that type of thing that's not included here.
Or a leak from a fuel component from a line or a dispenser, or it only involves fuel transfers.
Right. This is, you know, directly for spill prevention, overfill prevention. It's all related to the delivery of the fuel. So if like, say your spill bucket, his hose, it didn't hold the amount that was in his hose, it escaped from the spill bucket. Less than 25 gallons, it must be contained, immediately cleaned up. And if you can't contain it and clean it up within 72 hours, it must be reported to the division. But if you can, you know, immediately clean it up, you don't have to report it if it's less than 25 gallons. If a spill or overfill more than 25 gallons, of course, must be contained, immediately cleaned up, and reported to within 72 hours to the division, and begin any corrective action necessary. Say if it got into a stream, or a creek, something like that, into soil, into a ditch, you're going to begin corrective action immediately. And like Don said, this is strictly for during fuel deliveries to the tank. Of course, water disposal, when you're doing the hydrostatic testing, it's going to be, you're putting it in petroleum equipment that's been in contact with the petroleum. So what's the proper disposal of that water? We don't regulate that disposal of your test water. Who does? You can contact us, and we can put you in touch with, contact person with Solid Hazardous Waste Management Division, someone within our Water Resources Division, depending on where you're located. There's different opportunities for disposal with the Water Resource Division, but it's going to be site-specific. So, you know, if you have some questions about that, you probably want to give us a call or give one of them a call and discuss it with them. Well, where did you go? Oh, that's weird. Okay. Well, we'll go to overfill prevention equipment. If you have any other questions about, oh, what?
Yeah, Mitzi, this is Mark. If I could interject, the easiest way to get in touch with those divisions is to call your local field office. So we have 8 field offices located throughout the state that most of you know that are worked with us in the past, but the easiest way to get in contact with those resources are through the local field office.
Thanks, Mark. Yeah. All right. If there's any other questions on the spill prevention equipment, testing, monthly walkthroughs, anything about that before we go to overfill prevention? I'll move on, and of course, you know, ask as you can, as you want to.
Sure. Sure, Mitzi. There's no other questions in chat or the Q&A right now, but thank you.
Okay. Well, thanks, Mark. Overfill prevention devices are installed in the UST to help prevent the tank from being overfilled during a product delivery. There's 3 different types of overfill prevention devices. One is designed to stop product flow, reduce product flow, or alert the delivery person during the delivery before the tank becomes full and product is released into the environment. The stop product flow we refer to as automatic shutoff devices, flapper valves, the reduction of product flow restriction devices, those are our ball float valves, and the overfill alarm, the one that alerts the delivery person, is a high-level audible or visible alarm. And just a couple pictures of the 3 different kinds. The new rule requirement for overfill prevention equipment must be inspected for operability at least once every 3 years. And at a minimum, the test must ensure the overfill prevention equipment is set to activate at the correct volume level specified for that device, and that the device will activate when the petroleum reaches that level during a delivery. And just a little note.
I think
oh, go ahead.
If I could, I guess, sorry to interrupt you.
No, you're good. No problem.
We actually did have a question hiding under one of my tabs.
Okay.
From Brittany Boxer, and this is a question: are site check soil samples post spill bucket replacement required? If so, do they need to be submitted to the division, or can they be provided to the state inspector prior to inspection?
Did you say site check? Is that what?
Are site checks or soil samples post spill bucket replacement required? That's one part of the question.
Okay. Well, that would be that if you encounter contamination or suspected contamination during the removal, that's when you notify the division, and we would give you guidance on the next step, whether a modified site check would be required or sampling the backfill. You're going to report it to us, and we'll let you know what the next process would be.
So,
but it's not routine required.
Right. Yeah, but if you observe something more than incidental contamination, of course, you're going to run into some incidental contamination at most spilled buckets. But if you suspect there's been a more significant petroleum release, then yes, contact us and we'll give you the proper instructions from there. So,
right.
Does that answer your question, Brittany?
Did you unmute her?
Hey, sorry.
Yeah, hey, Brittany.
Hi.
Hey,
Hey,
that's
so
a great question.
I'm actually not a contractor. I'm an environmental compliance specialist. So part of my job is to make sure when we are notified that a spill bucket needs to be replaced, that, and certain states that I operate in other than Tennessee require soil samples and site checks to be performed no matter whether there's visible contamination or not. So I was just trying to get some clarification on my end for when we come across things like this, you know, what the next steps would be in my job as, you know, to make sure my vendor does everything properly and we report properly, if that makes sense.
That makes great sense, yes. And that's, you know, this would, of course, this is for our Tennessee rules, so.
Yeah, so Brittany, again, not routinely required. We don't require it at every replacement for sure. It's not part of our SOP, but if there is, if you suspect a release has occurred beyond just intermittent usual types of spillage, then yes, contact our field office and we will let you know what to do from there. So.
Okay, perfect. Thank you.
Thank you. It's a good question.
Thank you, Mitzi.
Okay. Just a note on the spill and overfill prevention equipment requirements in general. For UST systems filled by transfers of no more than 25 gallons at one time, they're not required to have spill or overfill prevention equipment installed. It's not required. And that would really just generally be maybe a waste oil tank that's, you know, not getting a transfer greater than 25 gallons. And for overfill testing, tank charts are important. They're required. It's a required part of all, you know, the calculations for your overfill device testing. If you don't have this available at your site, or the tank owner doesn't, says he doesn't, you know, don't have a tank chart, they can be created or found. Tank manufacturers, Steel Tank Institute, Xerxes, CSI, they maintain these records, you know, the actual company, for warranty claims. Steel tanks can be measured in an estimated length to generate a tank chart, or SIR, you know, if you're using a monthly inventory and a SIR vendor, you can eventually build a tank chart with the with all that inventory and flow through and delivery information. STI can almost always provide an accurate chart for any size steel tank. And there are some websites for creating a tank chart based on the information you have. So it's just important. You're always going to be able to create or find your tank chart for that specific tank. Just simple overfill device calculations for overfill alarm and ball floats. Since they're 90%, you're going to find on your tank chart the actual total tank volume. And when we refer to this through here, when tanks are installed, or our notification, when a notification form is submitted, they usually just put 12,000, you know, 8,000 gallons. It's just a round number, but no tanks are actually just a round number. So the tank chart, you're going to find that actual total tank volume on the tank chart, or in that automatic tank gauge. You know, it's going to be programmed based on the tank specific information. So that volume, you can use that too. You can multiply that volume by 90% off the tank chart, and then you're going to use the inches measurement to find out what that 90% is. And pretty much same for the 95%, the shutoff valves. You're using the same thing, but you're making sure that it's 95%. And the automatic shutoff devices are down in the fill riser, called flapper valves, flappers, and it's all part of your drop tube. And they're designed to, they just initially restrict and then shut off the flow when the product has reached 95% during the delivery of your tank. So you're going to always have that 5% at the top empty. So automatic shutoff valves need to be properly positioned and operate properly. The purpose of the operability inspection is to verify that it's installed properly at the proper height in the tank, and that it's going to operate as designed and shut off that flow so your tank does not get more than 95% full during a delivery to prevent an overfill. And there's different, of course, manufacturers, and the different manufacturers have different settings on the way that they operate. So you might have sort of a restriction setting, the initial setting, before it actually closes off to shut off the flow of product. So you could find out from the manufacturer. We can help you find it. If there's any questions in the field or what you're looking at and what you need to do, we can get you that information. And that first restriction just allows some of that product that's in the hose to be drained into the tank before the tank reaches 95% and it's shut off. That just allows, it's just giving it a little more cushion before 95% occurs. And for the operability testing, the drop tube is going to be completely removed from the riser. So visually inspect the shutoff valve, the floats, the whole device. Some work differently. Make sure there's no damage or any type of corrosion that's going to inhibit the function. Remove any buildup and debris. Manufacture or manually verify the float moves freely so that it's going to rise as the product level rises. There's the bypass valve, make sure it's open. You're going to go through the calculations of measuring the tank, using the tank chart or this ATG setup information, and you're going to do your measurements, make sure and verify that device is going to shut off the flow at 95%. So the tank will not be, the delivery will not go above 95% of your tank capacity. If, of course, if there's any damage or it's not operating as proper as designed, the device is damaged, defective, it has to be replaced. And you'll do an initial operability testing for that new device. There is a self-testing. There's several self-testing types of devices. So they were marketed as not having to be removed. You could just self-test it. The division does not approve these devices for the operability testing. You can install it, but we will still require it to be removed and visually inspected and calculated to make sure it activates at 95%. For the second type, audible, visible, high-level alarms, using that as an overfill prevention device. Kind of a two-part. You have it's outdoor device. It can be, like in the picture, a light, a speaker. It can be audible or visible. Most of them have both, and that's great. It's better to have both. And they're really loud. So it has to provide an audible or visible warning to the driver once the product level in the tank reaches 90% during a delivery. It requires a probe and part of your ATG system, so it's a setting. So once that probe floats up, it lets the ATG know, and then it triggers that alarm. It has to be located, of course, near where the drivers are dropping fuel. And it's sort of it's not a mechanical, it doesn't help to reduce, it doesn't help to stop. It's, simply a external method of an alarm. And the purpose of testing this the operability inspection, the 3-year test, you're verifying that alarm is operating correctly, that the alarm itself works, the light works, and that that probe is set at 90% of the correct calculated 90% volume of the tank. And this is a PEI process procedure for overfill alarm device testing. I mean, I don't have to read through the whole thing, but you know, you're just testing it against your programming in your ATG and the floats are operating properly. You have to take the probe out. You have to actually make an alarm, you know, see where that float alarms, check your ATG, what level is that. This is after you've done, of course, your tank chart calculations, so you know exactly what that level should be for that particular tank.
Yeah, got it.
Yeah.
And AV thing, maybe I had one of our folks said they lost all audio. Can the rest of you hear, the panelists, can you all hear?
Uh-oh.
You could send me a note in chat or Q&A.
Yeah, I can hear everything fine.
Oh, okay. Don,
okay.
You good? Okay. Looks like, oh, okay, great. It looks like maybe, hopefully that was just an isolated thing on
maybe it's called it on their phone or something, and it just, or like you said, the bandwidth. Maybe somebody had lower bandwidth.
Okay. Well, I just thought I'd check.
Yeah.
We'll continue. We'll continue on. But regardless, we'll have this recording available, so we should have that fairly soon as well. So, and also you can rejoin the WebEx using audio to dial your phone. So that's another way to solve that problem too. So I apologize if you've had any problems with the audio, but looks like we're good to go now. So thank you, Mitzi. Okay, great. All right. So part of this test, you know, you're going to, you'll have printouts, you know, that go along with this test to show that all the programming is proper, that it does alarm, and then it returns to the regular status. And then this is continuing the PEI version. And, you know, we'd be happy to provide this for you if you want to email, because I'm sure that's hard to read. If the overfill alarm activates when the tank is no more than 90% full, then it passes the test. Okay, we already really covered that. But attach the electronic alarm printout, which you're usually going to have that. So you're showing that it alarms at the proper level for 90%. And you'll have, of course, a form to submit with the calculations and, you know, the tank size, 90%. The third type, flow restriction devices. These are our ball float valves. This is located inside the tank, but it's located where the vent line exits the tank. So it's kind of part of your vent line system. And it is operates by restricting vapor flow out of the tank as the tank is filled during a delivery. And this is required to be set at 90%. So your delivery will not fill the tank over 90%. So as your tank fills, and once it reaches this in the picture, that little ball in the cage, it's going to rise up, and then it's going to seal up there. It's going to slow the rate of that delivery pretty noticeably, and the driver will be able to notice. Usually that hose will jerk, something like that, and he'll know to stop that delivery. And it's very important. These are properly installed, positioned at the right height, and compatible
with the type of UST piping, there's a lot of requirements for these. Okay. To function properly, all the ball float valves, all your tank top fittings have to be vapor type. So the only vapor escaping the tank is through that vent line. Also, they can't be used for suction piping. If the tank is overfilled, fuel could be released at the dispenser. They can't be used for pressurized deliveries that could overpressurize the tank. For remote fills, they can't be used on tanks with remote fills. If you have coaxial stage 1 vapor recovery, you cannot use ball float valves with it. And on emergency generator tanks with suction systems. And testing on the flow restriction devices, they will be removed from the tank, and this, I'm sure everyone's aware, that's been very difficult to do, even, you know, when you have good access to it. They've just been in there a while, and they're hard to remove, but you have to, in order to test it and do this, your 3-year testing, it has to be removed. You're going to do your measurements, verify that it is set to restrict the flow when the tank is no more than 90% full. And here's a good picture of it's removed. You're taking your measurements from, you're going to, of course, measure the piping device. You're checking on where it's going to restrict the flow of the vapors from the tank. You're going to visually inspect the ball float in the cage, make sure the cage isn't corroded, make sure the ball's intact, make sure it all, you know, flows, it works inside the cage. You're checking on the vent orifice in that vent restriction pipe, has to be open and located near the top of the tank. That's just kind of a slow release, so you're not pressurizing that tank. Use the ball float manufacturer's installation procedure to determine and make sure that it's installed properly. And if it does not function, here's the important, for ball float valves, these are being phased out. If it does not function as designed, it can't be repaired and it can't be replaced. Once it fails your 3-year operability test, they can't be repaired, they can't be replaced. You have to use another method. So you'd be installing the automatic flapper or the high-level alarm, audible visual alarm, and you'd be removing this ball float from the tank. Ball floats are still allowed on UST systems installed in Tennessee prior to October 13th, 2021. Of course, if it's installed and it passes your operability testing, then it can be put back in and used until it fails your operability testing. You cannot install, these cannot be installed or installed, that's one of the tests, installed or replaced or repaired. And overfill equipment devices, operation and testing, tank compartment ID, tank size, tank material. This is for all of them, you know, all 3 types. It's very important you actually have the correct knowledge of what tanks, what type of tanks, sizes of your tanks are on site. You can always check with the division on what the notification, what's been, you know, what's registered at the facility. If anything's incorrect, then we need an amended notification form updating that equipment. Even if you're using the tank calibration chart, the ATG setup, you still need to do some physical measurements on site. If multiple overfill devices are installed, all those devices must be operability tested. So if you have a flapper and a high-level alarm, you know, both of those have to have a 3-year operability test. If you have an automatic shutoff device with a flow restriction, the flapper must be installed to activate below the ball float. So right now. And there's times when that ball float may not be accessible, hasn't been removed. They just put in the flapper. It needs to be set at 90% or below. Hopefully you can verify where that ball float is set or remove it from the equation, because the automatic flapper must activate first. And record keeping for overfill prevention equipment testing. The 3-year overfill prevention equipment test must be maintained for 3 years for all equipment devices. So it's a 3-year test. You maintain it for the 3 years, then you do another test in 3 years. Just to reiterate, ball float valve overfill prevention devices, they can be installed prior to October 13th, 2021, and could remain in existing systems after October 13th, 2021, if it can pass the required operability testing requirements. And they cannot be repaired or replaced after our effective date of October 13th, 2018.
Yeah, I do have a question. If you
okay.
If I could interrupt you, from
Sure.
David McCamey. As I do the question, I'll try to unmute him.
Okay.
Here we go. David, I'll just let you, if you don't mind, ask your question.
Sorry, I got to put my mic down. I apologize.
No, you're good. You're
I
good.
hear you.
So you answered a great question that I was kind of sitting on hinge waiting on, would be the verification of the ball float. And if the ball float could not be verified and the installation of a drop tube device is installed, that you do want the second stage shut off below the potential 90% of the previously recorded ball float. So my question stems is that many operators use their ATG for ordering fuel, and it's based on the 90% that's programmed in the ATG for the remaining ullage. Is the state of Tennessee going to require that the ATG also be programmed no longer at 90%, but to the second stage shutoff recorded by the compliance tester at the location?
When the
That sounds like a Don question.
yeah, I think
that's $1 million question. I love it.
I know.
And it's one that, quite honestly, has been discussed. But since the ATG is not a component of the overfill device in question, I'm not sure we have the. It all ties into. Ultimately, most owners are using their monitor as a secondary overfill device, and that overfill alarm capacity is, and you're right, so that it never matches what is found in the tank itself, or there's no cross verification there. But that would be a really good practice to implement during these inspections, to verify that overfill alarm setting is configured exactly as is in the tank. That is not currently a requirement in our operability test, but it's one worth considering going forward.
Okay.
But it is a very good.
That's a great question.
Yes, thank you, David.
Yeah. Did that answer your question, David?
Yes, sir. So for us as a compliance specialist for our clients, we just need to alert them that, okay, you have a 90% ball float device that can't be removed. So your second stage shutoff is now at 88%. So we want to make this change also in your ATG to prevent your retail fuel division from ordering more fuel than what the tank capacity will now hold. And so that's going to be a recommendation on our part to the client or to the operator versus it being a regulatory requirement. That's something that the inspector will look for whenever they compare an ATG setup to the actual overage fill device in the tank.
If in the future we look at this issue, we may consider this a requirement, but for right now, I'm not sure that we have the regulations in place to require it. But that is a very good recommended practice for now.
Okay. I had a follow-up question on the ball float as well. So you have within this discussion, it advised that if anything on top of the tank, vapor recovery adapter or cap or anything that would leak vapor would render a ball float inoperable. That's correct and great. Will the state, in conjunction with an overfill ball float, require a 30-minute vapor test to confirm that it's operable?
The regulation for conducting tests on those devices is in place. However, it's in the air pollution regulations. So with that in mind, if for sites that are required to operate stage 1 vapor recovery equipment as a component of their system, the regulations for testing that device are part of the air pollution standard. Now, I believe it's the CARB language. It's the language from the CARB requirements. Is that an annual test, I believe, David, or is it I'm not sure how. In
some cities, your health department will require it to be an annual test, and then mostly are all third year testing. And I believe when you get Nashville, Knoxville, you're only required 3 years there, but you have to schedule that with the health department and run it through. In some cases, we have clients who have ball floats that have the 30 MV orifice installed, and the ball floats actually set at 95%. But in those cases where the ball floats are 95%, you want to make sure we do the 30-minute wet test to prove that it is capable of shutoff and flow restriction within that 30-minute guideline on a 95%. So the third question was, will the state allow the 95% as long as it meets the 30 MV testing requirement?
Is the device itself in question you're referring to designed as a 30-minute device? I think is there are some manufacturers out there that are still producing 30-minute overfill devices, but they're distinctly different. I'm not aware of. They don't seem to be common, but I would think if the manufacturer has a protocol for testing it, we would allow it under specific situations.
Yes, we actually have a client that's got a number of tanks in Tennessee that has the 95% ball float. And the question has been, will the state of Tennessee continue to accept it once this new rule comes into effect? Or, okay, hey, it's 95%. No, we're not going to do that. Go ahead and install, a flapper device or, a drop tube device.
Are you referring to, just one quick question, are you referring to the OPW device that begins restricting flow at 30 minutes and is shut off
yes,
at
sir.
95?
Yes,
Okay.
sir. Well, it doesn't shut off. It is a flow restrictor device. It just it just flow restricts at 95%. And then, the restriction shuts off at 95% at that 30-minute window. And so you have to have the 30-minute wet test to prove, that it's still, the orifice isn't clogged up, the orifice hasn't gone bad. It's still capable of preventing an overfill within a 30-minute window of the time it flow restricts.
Let me take a look. I can't answer your question for you at the moment, but let me do some digging and look at some of OPW's reference material and some of PEI stuff and see where they fall on this. Because we don't have it specifically addressed in our test procedure, or it is in the regulation, but it's a general reference. So I'll be happy to compile an answer for you.
Yes, sir. Yes, sir. Understood.
Make it available to the group at some point if possible. But that is another great question. Thank you.
All right. Thank you.
Thank you, David. Great questions. Good discussion. Thanks, Don. Mitzi, we're ready to go back again.
It's good to hear good questions like that, and kind of off the regular. That's good for us to learn too. And okay, there's some new rule requirements in regards to temporarily out of service tanks. These weren't part of our October 13th, 2018. These were actually in effect June 15th of 2021. Just to review, and this is our definition by rule. A UST system is empty when all materials have been removed using commonly employed practices so that no more than 1 inch of residue remains in the system. Your general TLS requirements, if cathodic protection is installed, it must remain operational. So, of course, the 2 most recent 3-year cathodic protection tests must be available, and the rectifier must still continue to be inspected every 60 days with the log maintained. If tanks are TOS for longer than 3 months, all the pumps, lines, manways, and ancillary equipment has to be secured. If the TOS UST system is empty, no monthly release detection is required. If the UST system has greater than 1 inch, then release detection must be performed. The new requirements for relating to spill and overfill prevention equipment, TOS UST systems are required to have the spill and overfill prevention equipment installed, even if they're temporarily out of service. If the TOS UST system is empty, then the 3-year spill and overfill device testing, integrity testing, is not required. These testing, the 3-year spill and overfill device testing, will be required when the tank has greater than 1 inch in the UST system. So those are just 2 kind of encouraging to keep that TOS tank empty to, avoid doing release detection and avoid doing the 3-year spill and overfill device testing. And Dawn, I think you were going to talk about this one. I wanted to, before though, just make sure, these 3-year tests have to be conducted on all of our Tennessee facilities before October 13th of this year, so we're getting real close to the deadline. And I know, all our service providers are really, really busy right now. So trying to get them all done. And, there's always people that wait till the last minute. And, I don't know if they'll actually get it done in time if they do.
Thank you, Mitzi. I just wanted to take a few minutes here and discuss this. I don't want to keep this over, so I'll be brief. But we shared this information with the owners as well, just as as an educational reminder, and I thought we'd do so here as well, that the fiberglass tank industry has, not only the industry, their representatives, PEI and the Office of Underground Storage Tanks with EPA have all given specific recommendations for the use of ball float valves, particularly with fiberglass tanks. The manufacturers are represented by the Fiberglass Tank and Pipe Institute. They published a paper in 2016 that's available on their website of the concerns of how a ball float valve operates within a tank. This is useful information to share with the owners, I feel like, even though it is a retroactive requirement, and the rules allow it. The issues that we've had with overpressurization of tanks during fuel deliveries, the potential of a ball float valve, if it's installed in conjunction with another overfill device, such as a flapper valve, could potentially interfere with its operation based on the tilt of the tank. The potential for vapor discharge from overpressurization, the buildup of vapors that are not returned to the tank. The UL listed fiberglass tanks, because of the excessive pressure that can build up during a fuel delivery, and these may be site-specific circumstances. If you have venting issues, if you have manifolded systems receiving multiple deliveries, or if you have configured systems that have vents that aren't sized with manifolded tanks to receive multiple deliveries, and you can ultimately result in damage to these, particularly with older systems that have settled and backfill is no longer as rigid as it once was. We're just passing this information along so that the owners can be aware that the industry has said, even though federal regulation all the way back to the 90s allowed the use of ball floats in fiberglass tanks, they are now making recommendations that those devices be removed or not used at all. So it is not, and I'll repeat, it is not a requirement for these to be removed, but the industry has universally reacted to it. What's your next slide, Mitzi?
It's just a cutaway, just showing the different types of equipment, where these are. This actually, Nigel made this, and he's got some great graphics that go with it, but they don't work in WebEx. So it's for an example. Just, here's your fill, there's your flapper, the ball float where it would sit, the probe where it would talk to your audible, visual, audible, external, high-level alarm, and that's really, oh, it did work. Look at that. Oh. So, there.
That's the latest WebEx, I guess.
I'm sufficiently stunned.
Yeah, I know. You're not used to that during tank school, are you?
No, it works. Nigel, it works.
I do have. Don, Rhonda Johnson had a question she directed at you, or maybe wanting you to talk about it, but I don't know if you covered it before. Do you see it?
I see it, yes. Rhonda, I was actually typing out the answer, but I can go ahead and just respond. To my knowledge, there are no individual, there are basically two major fiberglass tank manufacturers, and they are represented by as members of the Fiberglass Tank and Pipe Institute, but to my knowledge, I haven't reviewed their installer information recently, but whatever they've updated in there now didn't reflect, may not reflect what was installed 20, 25 years ago. I would imagine they would be Rhonda's question related to warranty requirements if ball plugs are installed. I don't think they could retroactively void a warranty for that sort of thing. So there's no reason to think that it would void a warranty in the event a warranty issue comes up from a fuel release. I would just recommend consulting each tank manufacturer individually to see how it would impact their warranty, because what's been put in writing recently would in no way reflect what was required 20 years ago or more.
Thank you, Rhonda.
Yeah, thanks, Don. I was just thinking about tanks, since that had been released, if that's not recommended, if it fell within that time, could it possibly do that if they've been installed for newer installations? But if somebody did that, but thank you.
You're welcome.
Okay.
Ready for the next slide?
Yeah, well,
Great.
pretty much at the end, I just wanted to